Welcome to another Demo Tuesday. Today we're going to talk about machine learning with SQL Server, where you bring your data and without moving it, you do your machine learning. We are Amli and we provide data solution and AI, and we are leading a consulting firm with global reach, and we are vendor agnostic, such that together we navigate the complexities of technology to find the right solutions that drive your success. That means we don't rely on a specific vendor. We talk to our customers and provide the best solution according to their problem. So today we're going to dive into machine learning using SQL Server. Most of the time, we do machine learnings in platforms like Python or R, and using maybe Google Colab or Jupyter Notebook. But today we're going to learn how to do machine learning inside your database, where you don't move your data, but you do your machine learning within your database, and everything is done in that platform. So inside the database, you can use two languages, that is Python and R, where you can run the languages within a database, and then you can execute and train your model. In this case, the advantage of this method is that you don't have to move your data. You execute script where the data lives. So even if the data comes again, and maybe you have new entries of data, maybe daily, you don't have to move your data to another platform. You just do your machine learning within your database. And you use common libraries for like pandas, scikit-learn, and RiverScale-Py, which connects the database to your Python and R. So in this case, we can do predictive analytics, anomaly detection, or operation machine learning at scale. The good thing with this is that even if when the data become large, you can be able to outscale because you're not moving your data set. So in order to do your machine learning in SQL Server, you have to make sure that during the installation, you enable the machine learning language to make sure that machine learning services and language to make sure that you can be able to use the machine learning capabilities inside the SQL Server. From the SQL Server 2022, you just enable in your feature selection when you're installing the SQL Server, you enable machine learning services and languages, and then you install separately Python and R in your machine. But there before in SQL 2019, we used to install Python and R when we are installing the SQL Server applications. So as you said on your feature selection, you select the machine learning services and languages. And if you are already having a SQL Server already in setup, you go back to your installation setup, and then you add feature. And in the feature selection, that's where you add now machine learning services if you had not added during your initial installation. So after now you've done that, you install and download your Python and R in your machine, and then you learn the specific packages that will help you to perform the machine learning capabilities. And another advantage is for scalability, the always on availability groups are supported for machine learning services. And from there, we're gonna see how to do this in SQL Server, and I will welcome Martin to pick up from there.
Thank you so much, Mr. Martin, for that introduction. So we've said that we have our data in our database, and we don't want to move this data so that we can perform machine learning on it. Rather, we want to move our model to the database. And in our case, we are using a SQL Server. So the first step is now after you've done the installations and you have everything in place, we get to the data preparation and splitting. So we have our data already here, but we have to ensure that it's structured and cleaned before model training. Why is this important? All of us went through school at some point, and imagine a scenario where the textbook you are reading from had some missing pages or didn't have some parts. Do you see how that could affect your learning? Because you won't get the full information. So same case with our data. We are using an example of a model to predict equipment failures. So if our data has missing or incorrect entries, then our model will learn incorrect patterns, and that will lead to bad predictions. As for splitting, again, when we were in school and we were learning, we used to have textbooks that had revision questions, maybe at the end of every chapter or at the end of the book. So it's the same case for our model, whereby we split the data into two. Part of the data is used for training, and then part of the data is used for testing. And the ratios are that the training data has to be more than the test data. So another example is a chef. If a chef practices on, let's say, 70 recipes, then you can trust this chef to test their skills on 30 new recipes. So how we go about splitting, we first randomize the data because we don't want to have biasness. So we randomly select the data that we'll use for training and the data that we'll use for testing, so that you wouldn't want to train your model, let's say, on data from summer months and then test it with data from winter. You see, there'll be a disconnect. So that's why we randomize to ensure that there's fairness and unbiasedness in training. And then after we do the data preparation and splitting, then we get to create the training procedure. So a stored procedure in SQL Server it's like a reusable function that helps us automate tasks. So in this case, our stored procedure will now load the data from the SQL Server tables and then perform encoding for us, which is converting texts. Like, for example, failure type is a text. Maybe it's too much heat, or yeah, so it's a text. But now our stored procedure will convert that into numbers, which the ML model can read and train from. And then in our demo here, we've used random forest for the training, and it's not restricted to random forest. You can use any other machine learning algorithm. For us, why we used random forest was because random forest operates with multiple decision trees. So it's like you have a group of experts who are trying to predict equipment failure. So instead of relying on one expert, you ask many experts. So in this case, each tree is trained on a random subset of the data or a column. So a tree will look at one column, the other tree looks at another column. And the reason we're doing this is to reduce overfitting, and overfitting is where the model is learning from the noise instead of the actual pattern. So that's the reason specifically for our model, we went with random forest. And then after we train the procedure, we get to store the trained model. So why do we store this model? After training, we don't want you to always train whenever you want to view a prediction. we want to save this model so that you can use it later to make predictions without the need for training it. So in this case, now we store it in a table. For example, our table, we've named it equipment failure model. And then that way, anytime we want to test it, we don't need to train, we just need to call it. There's a code for calling it. You just call the model and now test the row or the new data that you want to test on the model. How this works in a different setting, let's say you've created a fraud detection system for a bank, and then you've already trained the model and you've stored it in SQL. So we normally automate this in a sense that whenever each transaction comes in, the system retrieves the model, checks if the transaction is fraudulent or not. So that's like a process that's quicker, and you don't need to keep on retraining. That's majorly the essence of storing this model. And then in our case, for the equipment failure, we'll actually show you in an actual demo how after all this training, you just need one line of code to call the model, and then you can now test with your data. And then after storing, we get to now do the predictions. So in making predictions, remember we said the reason we used a stored process, a stored procedure is to automate the process. So once we have it stored in the SQL Server, we automate it by loading the trained model from the database. Now, after you call it with the line of code, and then retrieving the test data. Because, for example, for us, you saw we stored after splitting the data into train and test, we stored each in a different table. So how we do the prediction, use load the stored model from the data, retrieve the test data from the actual table, and then use now Python to apply the model and predict equipment failure. And then the result is a comparison between actual versus predicted values. So in a day-to-day setting, that would work where every day we have new sensor data in our equipment, let's say temperature, pressure, vibration level. We have that collected every day and stored in, let's say, equipment failure test table. And then whenever we want to predict, we just load the model, apply to this new data, and then predict which materials are likely to fail. So after that, we now get to analyze the model performance. So we want to know how accurate is our model, and are we getting the right results? So in doing that, we have something we call the confusion matrix, which now gives us the true positives, true negatives, which is basically the actual versus predicted. So for example, if it's true positives, these are the correctly predicted failures. If it's false positives, they were predicted as failures, but they were not actual failures. And then false negatives were the missed actual failures, and true negatives are the correctly predicted but no failure. So we're going to show you a dashboard with this created so that you can be able to visualize it better. And then with the confusion matrix, you can now go ahead and compute the performance metrics so that you can know our accuracy level. And in this, we have, for example, precision, which is how many predicted failures are correct. And we get that by dividing the true positives divided by true positives plus the false positives. So we want to see how many of the actual failures were how many of the predicted failures were actually failures. And then the recall, we compute that from the true positives divided by the true positives plus false negatives. So again, it's to know the actual failures that were identified. And then we have F1 score, which is basically a balance between precision and recall. And it's useful when we need both accuracy and completeness. And for that, we have a formula for it. We'll show you, which is 2 times precision times recall divided by precision plus recall. So in our setting, we did this with equipment failures prediction. So what this means, if the precision is high, it means that our model rarely gives false alarms. So we can use this model for the critical systems. If it's the recall that's high, then that means that our model rarely misses on an actual failure. So that tells us that we have fewer unexpected breakdowns. And then F1 score, like we said, it's just a good balance between precision and recall. And then after that, it's the reporting. So we use Power BI to create a dashboard that will show you the model performance, both precision, recall, and even F1 score. And then we also show you the trends in machine failures over time. And we also get to break down the false positives versus false negatives, which you can use to improve predictions. And again, we're going to show you this in a moment. So we'll actually switch to the demo right away, and then afterwards we'll show you the next steps. So welcome, Mr. Martin.
Thank you. Thank you for that. That was a good flow. So the next thing, we are going now to show what Martin has been talking about here, and to show now using the SQL command, and you can be able to do this. Remember, we said that the first step was to do data preparation, and in data preparation, we have your data in SQL Server. So the first thing you do is to add a random variable in your data set. So you alter your table and then you add a random variable. So now, after now you add a random variable column, you also now update in case a new data appears. You have to update the random variable so that now when you're doing the splitting using the using the new column, even the new data has the assigned the random variable. So you just assign once again to the new data, you assign a random variable, and then you can use that random variable to do your splitting even with the new data set. So after now you have your data, then you can do your training, you can do your splitting, and then you can be able to make sure that it's randomized in such a way that it's not biased. So we have here our data set here. It's called equipment failure. You can check some few. So our our original data is like this here. We have a few columns. That is the product ID, type, temperature, like process temperature, that is air temperature and process temperature. We have rotational speed, torque, tool layer, failure type, target, and random value. So you can see here we have added this column for random value, and anytime now we regenerate this process, it assign you can set it to assign a new random value, or you can just add a random value to the new data set. So this, you're gonna use this random value to generate our two data set. That is we have the test data set and also the training data set. So now, after now we've created the two data set, we now can be able to do our prediction. So you just create a table here. You just create a table for where you will gonna store your you're gonna store your equipment failures, and you just use drop the table if it exists, so that when you're running this process once and again, it won't tell you that the table exists. So after you store you create the table, now you can be able to do what we call the training. So here is another table that will come and see its importance in the performance evolution, called the feature importance. There's a way we want to see, like, among the variables that we've used to in our prediction, which is the mostly used, which is mostly causing the failure, or which is being affecting strongly our target variable. So we store the table for feature importance, so that we can be able to display it in the Power BI when we are doing the presentation. So we said number one, we're gonna create a procedure called training failure, train equipment failure model, and then this procedure is going to execute. So this function here, sp execute external script, is the one now tells the SQL Server. Now we are not using the SQL command. We've now gone to using the Python command. So here now, from this place now here, we see these are not SQL command. These are Python command, like import pandas spd, import pickle, import sklearn, preprocessing, and then you also import the random forest classifier, which is the algorithm that we're gonna use. So this one now we are using now here is when we come and realize how we are using the Python inside the SQL Server to do our machine learning. So after we do the encoding for categorical, we prepare the training data, and then we train now this here. We train our model using random forest classifier, and these are the metrics that we're gonna use. And after that, we extract a feature importance. This is the one that was explaining that we want to see that in our data set, which are the variable, how are the variable affecting our outcome, our output, our target variable. So after that, we're gonna select the data that we want using SQL Server, and then we're gonna put everything now in the model. And when we have stored the model, now we store the model in the table that we had created. Now we can call the model again, and then we can be able to use it in a prediction. So the next step was to do what we call we now predict. After we predict, we create another stored procedure for predicting the, here in this case we call it the predict equipment failure. So we create now this stored procedure that calls the model that we already trained, and then does the training. Here we say you get the trained model from the database that we had training, and then you have to check if the model exists. So if it doesn't exist, you can go back and retrain the model again, and also make sure that the model exists. So we now call the model, and then we execute again. We come here, and we go back now to tell SQL that now we've gone back to Python language. We do our data pre-processing, and then we call the table again, and then now this one combines with the results. It sets the result and stores in a table. So it picks the table. It picks the equipment test. So here you can see, in this case, we are picking this data from equipment test here. But in our first stored procedure, we picked from the equipment failure train. So here we are picking data from the training data that trained the model. But in this case, we are doing all this process. We are using the test data that we split, so that now we can test the model with the new data and see how it's going to perform. So it creates this table after it has as it completes the prediction, and then adds another column here for predicted failure. So we have the target. The target was the column that was there for the failure, and then now we have added another column for predicted failure. So the last step is now simple. We have a table now that we store the predictions, and then this table, after we've created this table, you can in case you are relearning this process once again, you just clean the table again, and then you see truncate, and then you can insert again. So in this case, in order to perform everything, to perform your model, you just have to run these two commands. So if you run these two commands, have done the thing. So when you want to let me come here again. You want sorry guys. So when you want to run your model, you just have to learn your insert into you just have to execute this procedure, and then it insert the data to the equipment failure, and then from there it's become easy for you so that you can be able to, because you've already done other procedures. So we'll learn this process once again, and we'll give it some few minutes.
Yeah, thank you. Thank you so much, Martin, for taking us through the demo piece. So we've shown you a machine learning model, how you can take it to your server, how you can use it to do predictions on your data while the data is in your server. You're not moving your data. So what we've shown you was the model, the training process, the data cleaning and all that. And we want to move this to the next level, that we want to move beyond failure prediction to predictive maintenance. We want to be able to estimate the time before failure so that we can proactively schedule maintenance in advance. Through this training process, we want to provide early intervention insights so that we can reduce downtime, because some of our equipments are important and we need to use them with the minimal downtime. And then we need to optimize resource allocation by forecasting the failure probability and severity. So what this will impact your organization, you'll be able to plan ahead for maintenance instead of reacting to failures as they happen. And then this will also minimize disruptions and extend your machine lifespan, because now based on the data, based on the feedback from the model, you can do your scheduled maintenance in advance. You can know which equipment needs which kind of attention to prevent the breakdown. And then of course, from the ML piece, we now introduce AI, the copilots and Azure OpenAI, whereby you can interact with this model from your chatbot, whereby you're not the one running the model. You just instruct your copilot, run this model for me, and the copilot also breaks down the feedback given. Yeah, so that's where we are headed with this, and would like you to be on the lookout for our next video as we show you this in action.
So now I had studio, when you've created this model, sorry for that, we had some error here. You just have to run one line of code. And when you run this one line of code, it processes everything for you. So you can see here now we have a new data set where now you have the predicted failures. So after now you've created your model inside your SQL Server, you don't have to go and now do all the process for cleaning because you've created a stored procedure. You just run the stored procedures and then boom, you get your results. And then from now result, you can be able to now to see whether you can be able, as Martin has said, we want to make sure that an end user can be able to intervene a maintenance, for instance, of an equipment. So you just display the data in a report, and after display the data in a report, you can be able now to do your prediction, and you can see maybe we need to do a repair on a certain equipment. So that is how we do the machine learning in SQL Server. And we said advantage is you're not moving your data. And then when you've created your model, you just need one line of code. And you can also schedule your stored procedure so that it runs on specific times, maybe after 6 hours or maybe daily, and then your model will be updated. So here is the report that we created that to measure the model performance. You can see accuracy, precision, recall, and everything here. And you can see your confusion matrix and feature importance. Here, feature importance I was explaining is you can be able to see which of your variables is mostly affecting the prediction. So in this case, it's torque followed by rotational speed, tool wear, air temperature, and then process temperature. So, and then you can be able to see your data set. You can be able to display your data set. So that is our demo for today, and we really appreciate. Let us follow our page for the future of this machine learning model in SQL Server.
A question?
Yeah, you can.
Okay, so since I've seen from your code you are truncating a table in order to load the new trend model inside that table. So I want you to imagine in a scenario we are having a huge data set, because right now you are dealing with just a sample data. What you're doing, you are removing the entire data from the table, then you are loading a new one. So I think what should be done in case of having so many data, it's incremental loading of data. So you don't have to interfere with the one which was already trained. The one which has just come, the new data, just add the newly trained data, that particular table, the row following the last row which was trained. So I think in that regard, it will ensure that even the load time your query will take to execute will be highly reduced. So it was just an opinion for maybe future in a scenario or in an event where we are having a lot of data dealing with.
Yeah. That's actually a very good opinion. Yeah. When you have a huge data set, you don't, and then you are getting, let's say, for example, you're doing million transactions per day. So in a million transactions per day, anytime you're doing your predictions, you'll just load the new data, train the new data, and make prediction for new data, and then you'll add the new data in the prediction for that is existing table you just earned. But if you are dealing with data that is not large, you can be able now to truncate and add the new data again. When you are truncating, it's when you are repeating the whole process. Remember I said now you've stored your procedure, you just execute your procedure. When you are redoing the whole process is when now you truncate your table and then you load everything. So thank you for that. It's a good one.
Okay, I also have a question, and mine is related to the splitting of data. And so we saw that in the model that you have built, you have been able to split 70% of the data for training and 30% for testing.
So my question is, do we have like any criteria that is able to guide us on like how do we split the data? So and how does splitting like help in the effectiveness of the model? And can we even go as far as having like 50% of the data for training and 50% of the data for testing?
Thank you, Sami, for that question. When you're number one, I want to highlight on the importance of splitting the data. For instance, let's imagine you train with all the data, and then you test with all the data. So the model will be so perfect. It will give you accuracy 100%, and because it's knowing everything that you've trained it with. So the reason we train the data is we want to see now when we have trained this model with this data, and then we expose it to a new data set. How is it going to behave? That did it learn the pattern in the data set? So that's why we train. And in most cases, we do have that the training data set should be more than the testing data set. And this is where we say about the power of large data. We train a model with large data so that it learns the trend, so that even when a new data set comes, it has learned all possible trends and it can be able to predict. So I'm not sure whether there is criteria. Maybe Martin can help me, but mostly we use 70 or 80% for training, and then when we have the other data, we can use it for testing. But when your organization have a new data set, you keep on improving your model when the new data set arrives or comes into your database. Thank you.
Yes, so for that question, Sami, it's just as Martin has said. And remember our example of a classroom. We are training this model to learn from the data. So the more books you read, the easier it would be for you to do the exam. So in this case, the more the training data, the better the expected outcome. So you can even do a 95% data used for training and only 5% for testing, or whichever percentage, but the training data is ideally more. And then you also remember the bias. You need to prevent biasness through the randomization, or just we call it stratified sampling. Yeah.
Okay, thank you for that answer, and that was a great presentation. Thank you.
I have a follow-up question to the truncation of data. I think I noticed in the demo you are running the store procedure that reloads the data. And I think I heard you mention that you can run it on specific times. Is it possible to run your store procedures is it possible for you to collect this data continuously rather than scheduling the store procedure to run on specific times?
Okay. Thank you for the question. So for the purposes of our presentation, we used the static method. But as Malvin suggested, when you use incremental loading, we're ensuring that it's only the new or changed data instead of reloading the data set. So with now the incremental loading, you can be able to test each data as it arrives, as opposed to what you are doing now, which is static with what you have already stored. So we're going to use that, and then in the next demo, we can present that with the incremental loading.
Thank you.
Mine is really not a question, but more like an input. When we're doing stuff in this, like what do I call this? To notify someone something, and then we're doing reporting. Do we also generate email notifications or just relying on reporting in that case? Because I'm assuming, let's say we're trying to detect something is going wrong, and we said we were scheduling that at a given time interval, and we also talked about what Lena just raised here, being able to have it run, continuously. But what about notifications? I'm not looking at my reports very frequently. Can I get an email? Can I get a notification? Is that something that can happen?
Yeah, thank you, Adam, for that. Yeah, when now you've created a running procedure, you can create a procedure that if certain things happens, for example, if the prediction goes beyond a certain point, or if the data point gets to a certain point, then we trigger a notification where you have to go and check your report so that you can take a point of action.
Okay, so thank you, everyone. Having no other question, we'll end it at that. Thank you.